By now you should have done the introductory reading and seen the videos and have some idea of what happens if you have to graph pressure, volume, or temperature. On the Moodle you have the gas laws simulation. We'll first be working with the volume and pressure simulation and later the pressure and temperature. These links are also found on the handout for this lesson. The volume and pressure simulation looks like this. The key thing that you need to get out of this is you need to understand what a graph of pressure versus volume will look like. I want you to play around with it a little bit yourself, but I'll show you quickly how it works. You simply click on Start and you can see the gas particles moving around inside the container. If you increase the volume of the container by pushing it up, then you can see what happens. The gas particles, the same number of particles moving with the same speed but through a larger space, they collide less frequently with the sides of the container, and because they collide less frequency, the pressure is lower. So you can see that happen here, where as the volume increases, the pressure decreases. And if you graph that 1 over pressure, you'll see this relationship here. If you grab the container and you make it smaller and smaller and smaller, then you'll see that although the gas particles look like they're moving faster, they're really not. It's just that they collide more frequently with the container because there's less space for them to move around. And you can see that here, as the volume gets smaller and smaller, the pressure gets larger and larger. So you get that nice little 1 over curve. Or, put another way, the pressure is proportional to 1 over the volume. As the volume gets bigger, the pressure gets smaller, and vice versa. Now, if you go back to the Moodle, you'll see the next one is pressure and temperature. Also, that link is on the homework handout. If you look at pressure and temperature simulation, it looks like this. Once again, I do want you to play with it, but I'll run you through it real quick. If we press Start, you see the particles beginning to move. If we decrease the temperature of the container, you can see the particles move much more slowly. If we increase the temperature of the container, you can see the particles begin to move faster and faster and faster and faster still. Obviously, that's going to cause the pressure to rise. Now, for some reason, this is not doing it with this particular time that I'm running it. So I do want you to play around with this a little bit, because I should see the pressure and temperature begin to change. Let's pause it. Start it again. Nope. Let's just try one last thing. I'm going to assume that when you run it, it will actually work for you, even though it's not working for me. But we'll try it one more time, just in case. Here we go. Ready? Start. There we go. That's what I wanted to see. The more you press the temperature up, the higher the pressure on the container. The more you lower the temperature, the lower the pressure on the container, simply because the particles are now moving very slowly, and so they don't collide very often with the container, and they don't collide very fast, so the pressure is very low.